Hey, what's up, everybody? This is Coach Sharf, and welcome back to my Algebra 2 / Advanced Algebra notes videos. Today, we are going to take a look at what now in the last 2 years, 23, 24, 24, 25, has been the last new lesson / topic in Unit 1, our statistics unit. We're going to cover standard deviation, normal distributions, and z-scores. So let us jump right in. There we go. All right. Here. My head over here. All right. So with standard deviation, normal distributions, and z-scores, there is still a focus here on data collection and data analysis. We could still tie it back to that. But these topics are more probably what you would expected to see out of a statistics unit coming in. We touch on probability with the normal distributions, and then the standard deviation and z-scores. That's another statistic that we can take from a data set like mean, median, and mode. Did not have this written out. Let me write it here. I'm actually going to kind of follow that data set I had written on the board. I'll look up there and copy it. 63, 68, 71, 74, 79, 82, 86, 86, 89, and 92. All right. So if we just have this set of, let's call them test scores, there's 11 of them. We can calculate the mean, add them all up, divide it by 11, which would be 73.6 for our sake. We'll round up to 74. The median, I already put it in order. It's going to be the middle number, which is 79. There's 5 numbers below it, 5 numbers above it. So the median is 79. The mode is the number that appears the most, the data point that appears the most. There's only one that appears more than once, which is 86. Okay. I'm actually going to try to work this out in my head right now. I didn't do it in class. You can also get the standard deviation. I'm going to tell you all how in a second, but so probably doesn't do you much good right now, but I'm throwing you with the other 3 to show you that you can get standard deviation for this would be, excuse me. $108 divided by 11, which is going to be just under 10. 9.727272. I did that right, which I believe I did. No? I did not do that. Excuse me, 9.81818. One number off. So that would be the standard deviation. Well, how would I get the standard deviation? The standard deviation is the average distance all the data points are from the mean. So I'd pick these numbers randomly. It was a good thing to mean. I know we rounded it up. It was actually 73.6 if you did it. We rounded up to 74. But coincidentally, 74 was one of our numbers, so it kind of helps. Okay. So this test score of 74 is 0 points away from 74. And then we can kind of just, coincidentally work off of this 74. 71 is 3 points away. 79 is 5 points away. 68 is 6 points away. 74 is 8 points away, or 82, excuse me, is 8 points away. Y'all get the idea. So you're getting the distance all these numbers are from the mean, which in this case is in our data set. So you're going to have 11 distances if you add them up. You're going to get one for 74 too, which was 0. So you get 11 distances. The total I got when I added them all up was 108 divided by 11, which is what gives you the 9.81. Okay. Well, again, it's 9.81. I think it's 818, so technically it would be 2, but whatever. Not important. So you aren't actually gonna have to calculate the standard deviation. You could calculate it by hand. There's a formula to do so. There's also a way to punch a data set into, I don't have a calculator handy. I'm gonna have to go grab one in a sec. There's also a way to punch it into a data set in the calculator and calculate it. Not gonna make y'all do that. Any problem where you need the standard deviation, it will be given to you. Okay. A normal distribution. We talked about this with the Gaysberg address assignment. So it's a regular spread of a data set, and it follows the empirical rule. We'll talk about the empirical rule in a second. But if y'all remember, we had these curves that we did over the dot plots for the Gaysberg address. So you had normal distribution, skewed left, skewed right. Just kind of making a dot plot underneath this. So the idea about the normal distribution is most of the points are centered around the mean. Let me kind of draw in this one to be in the tall stack. So let's say the mean just happened to be right here. Okay. Most of the data points are centered around the mean, and they kind of spread out evenly in both directions away from the mean. Okay. So that's the idea about it. The actual spread in terms of what percentage of our data points, our dots in this case, again, our dots represent test scores or number of soda bottles that had winning caps, average length of the words you picked out from the Gaysberg address, the stuff that we've done dot plots for throughout the unit. The average percentage of those dots within certain distances of the mean. So here's that, the empirical rule, aka the 68, 95, 99.7. So this shows the expected percentage of data points that fall 1, 2, and 3 standard deviations away from the mean. So 1, 2, and 3 follow 68, 95, 99.7. If you are looking at that diagram, let me actually pick a corner to put this back up top. So I'll use the test scores as an example. I actually had them, which I did in class, on the next slide, but I kind of erased some stuff, so I'll work from here. Okay. Let's use a different. So there's that first data set I had. I also kind of did a different example with, I think, all the classes of a different set of test score. So that one I didn't write anything on the board. I just kind of pulled some numbers off the top of my head. So if our average test score was 80 and the standard deviation was 6, okay. If I add 6 to 80, I get 86. If I subtract 6, I get 74. So one standard deviation above the mean, 80, is 86. One standard deviation below the mean, 80 minus 6 is 74. So in that range now, 74 to 86, we would expect to find 68% of our data points. In this case, again, they're test scores. In a class of 25, that means we would expect to find 17 of the 25 dots from 74 to 86. Okay. It's not going to be exact. Okay. I mean, there's until you get to, I mean, there's decimal answers, so it's probably technically not all the way to 1,000, but with 25 tests, I'll use 25. You can get 17 out of 25 is 68. The closest thing you're gonna get 95 is 24 out of 95, which is 96. And then obviously 99.7 would have to be, you would just have to go ahead and go up to 125 out of 25. So you're literally not going to get these percentages every time if you map the data out. This is just what it averages out to. Without trying to go too deep into this, I try to explain it in class. This works because if your data starts to spread out too much, okay, so instead of 68% of your data points falling in here, let's say it was only 40%, okay, what that would probably wind up meaning is your mean is not actually going to be 80. You need to go back and recalculate and see what it is. It might be 80, it still might be 80, but then even if it was, your standard deviation would definitely be off. Your standard deviation would need to be higher. So instead of 6, it might need to be 9. So this would need to be 89 and 71 instead. And then you might go back and plot your points again and get a percentage of them closer to 68 being in there. Again, if y'all are trying to, you had the question, well, how do we know that's what those percentages are going to be? It's going to be close. Again, it's not necessarily going to be exact, but it's going to be close, because if it was way far off from that, then either your mean wouldn't be right, or we'd have to go back and recalculate it, basically your mean and your standard deviation, and kind of recalibrate everything. So 68% within one standard deviation, we spread that out to 2 standard deviations. So if we added 6 and subtracting 6 again, 92 and 68, we expect to find 95% of our test scores. Okay. I didn't have this colored in class because I don't want to confuse y'all too much, but at 95, that did in the Khan Academy video, includes the 68% plus these extra sections, which add up to 27%, which gets us up from 68 to 95. And then third standard deviation, add 6 again, which would be 98 and 62, would be 99.7% of our data points, in this case, our test scores. So, we would basically expect to find all of our test scores between 62 and 98. Because if you had one lower that was, 98, unless there's extra credit, you can only go up to 100, right? Like 98 up to 100, that's 2 extra points. So it's not really going to move your mean or your standard deviation. But if you had a 0 that was way down here as an outlier, what that probably means is your mean should probably be a point or 2 lower. And since it's so far away from the mean, it would be 80 points away from the mean, or even if it went down to 78 points away from the mean, your standard deviation is actually going to go up. So instead of 6, it might be 8 or 10 or whatever. So this is the basic layout of the empirical. If you look, again, I have it broken down to these sections. The 68 is not necessarily broken down, but we assume the mean is in the middle, 50%. And so if we actually draw a line there, then we can split it up. That's what I have on the next page. It's this more detailed breakdown up here, okay? So again, you might have gotten these numbers in class. I'll rewrite them when I was doing the test score example. So 68 split in half is 34 and 34. Now, I said a couple minutes ago, when we jump from 68 to 95, that's an increase of 27. Everything's symmetrical. So that 27 is split evenly to both of these wings. So it's going to be 13.5%, 13.5%. That doesn't quite look like a 3. Let me make sure that's more clear. 13.5%. Okay. Then both the orange sections are 2.35%, and the outlier sections, the 0.15s, are 0.15% each. Okay. If you add all 8 of those sections up, it gets you 100% of your data points. Okay. This more detailed breakdown is honestly, I'll probably give you both for the test, but this is honestly the one you can use to answer basically every question I'm going to give you in terms of a normal distribution, particularly for the worksheet I'm about to show a few examples. Okay. Z-scores, I think I'll make a separate video for this, and then get it posted, but I'll talk about it right now real quick. No, I'll save it for the other video. I'll save it for the other video. So I'll just focus on normal distributions right now. Okay. All right. Let me pull up the worksheet. I think I got to do new share. Here we go. So there was a Khan Academy video as well. As I said, I'm going to hide my head. I'll post that link when I post this assignment in Canvas. But this is the worksheet I gave you. I'm going to go ahead and go over a few examples. Okay. Let me annotate. So we're going to look at 1A. Okay. We're talking about some distributed scores on the math portion of the SAT. They're roughly normally distributed. So when you see normally distributed, you know you're talking about the empirical. Okay, that's going to be kind of the giveaway above all else. With a mean of 500 and a standard deviation of 100. So if y'all look at the diagram they gave you, 500 is in the middle. And then they added 100, 100, 100, subtracted 100, 100, 100. And it shows within this first standard deviation, 400 to 600, you expect to find 68% of your data. Next one out is 95. Third one out is 99.7. Okay. The thing about them doing that, though, is for most of these questions, this isn't going to be enough. We're going to have to go back and look at the more detailed breakdown. Okay. So let's start with 1A. That's what we're going to look at. What percentage of SAT scores are above 400? We're looking for a percentage. So we're trying to add up these sections. Okay. Are above 400. 400 is right here. There's one standard deviation below the mean. Okay. If we were just looking at this graph, okay, just the one that's given. So we want everything above 400. On a number line, everything above is going to be to the right. I know I've got this whole section, which is 68%. Then I've also got this, and this tiny little wing right there. So I got to figure out what those are and add it to my 68. There are a couple ways to go about it. I think the easiest one, as I told y'all in class, let me go back to active, is by just adding up your sections from this diagram. 400 was right here. Okay, it was one standard deviation below the mean. So starting right here, we're just going to add up 34, 34, 13.5, 2.35, and 0.15. That's the quickest way to go about it, in my opinion. It's a few more numbers to add up, but as long as you got the numbers right, I mean, you know how to type in the calculator, you put your decimals in the right spot, you'll get the right answer. You know, if we go back to this sheet, this is kind of the approach they took on the first problem in the Khan Academy video. You know, if we know that this is 68%, then everything outside of it has to be 32%. Okay? 68 and 32 is what adds up to 100. And if the whole idea of this normal distribution is it's symmetrical, y'all can't see my head right now. There you go. The whole idea of this whole thing is it's symmetrical going both ways. Then you're going to have everything on this side is going to be 16%. And then everything on this side, probably should change colors. Everything on this side, 16%. And everything on this side, 16%. So above 400 is this 68 right here plus the 16, which is 84. Okay. But again, if you go back to the active board and you add all 5 of those sections together, which was 34, 34, 13.5, 2.35, and 0.15, if you add that all up, you'll still get 84%. So it is 84%. If any of y'all are watching this video, just dawned on me today after seeing a few of your answers. There is a chart. I showed it to every class. I'm recording this on Wednesday, so I'll show it to the classes Thursday if anybody happens to watch this tonight before you see it in class. There's a chart where you can turn z-scores into percentages. And a z-score of 1. It's still basically the same idea of this. Instead of saying 84, you get 84.13% instead of just straight 84. So I think some of y'all are getting that from a previously filled out worksheet online. Which just means you won't know how to do it come test time. So yeah, if that's what y'all are doing, as long as I don't blatantly see you doing in class or you clearly copied somebody else on your homework, like I'm not gonna fight that much on it. You're just gonna fail the test, and once you fail on my test, you can take the class again next year. So that's on you. Anywho, so that's 1A. Okay, let me clear all this out. Well, actually, let me scroll the mouse. Oh boy, it will. That's exciting. All right. So let's go down to 2A. So on 2A, I'm going to show y'all, I think, the best way to draw these curves. So on 2 and 3 and 4, you're not going to have the normal distribution curve drawn for you like it is on number 1, even though, again, you kind of got to get that more detailed breakdown. But I would draw your x-axis. Pardon me if this is not perfect, but I'm trying. That's not terrible. This side's a little higher, but whatever. Take. So draw your normal distribution curve about right down the middle. Draw a dotted line, and right in the middle is the mean, is the average. Okay. So in this case, 175. And we have to go out from the mean 1, 2, and 3 standard deviations. But what I think is easier, particularly if you can't do some of this math in your head and you need your calculator, I would do, I'm trying to think how this is going to look. Yeah. All right. So I would do, I hope this is right on the recording and doesn't get flipped, but I would do everything to the right. So +1, +2, +3 standard deviations. I would go ahead and add all that in at once. So this +1 standard deviation, I'm going to do 175 plus 37. That's what you can type in your calculator, and you're going to get 212. 175 plus 37 equals. Should display 212. You would then again type plus 37 to get your second standard deviation equals 249. Do it one more time, plus 37 equals, and get to 86. Okay. Then subtracting. Let me you gotta get a little closer. There we go. All right. So subtracting now, going the other way, we're getting 175 minus 37, which is 138. Subtract it again, which is 101. Subtract it a third time, which is 64. Okay. So you've got your curve set up now. And I didn't do this in class for the one I did on the board, which I'm sitting here looking at right now. But again, if you want to go add in I would do the more detailed breakdown since you got all 8 sections. So 34, 34 here, 13.5, 13.5, so on, carry it out. So that should be enough for you to answer B through G. All right. I kept this up here for a reason because I'm going to carry it down here to number 4. So y'all would do the same thing for building your curve on number 4. But let me talk about it. The incubation time for, oh yeah, let me pause first, I guess. 3 is basically just repeating all the stuff that you do on 1 and 2. There's nothing new on 3 that we're not covering on 1 and 2, so that's why I skipped. All right, number 4. The incubation time for Rhode Island red chicks is normally distributed with a mean of 21 days and a standard deviation of approximately 1 day. If 1,000 eggs are being incubated, how many chicks do we expect will hatch? So first, the total mean is 21. Standard deviation is 1 day. 22, 23, 24. Shouldn't even need to calculate for this one. 20, 19, 18. Okay. We are still doing the same thing. We're going to have to go in and find percentages. Okay. We're going to have to go in and find percentages. So again, this might be where you want to do 34, 34, 13.5, 13.5. Okay. I'm just going to do those 4 because I'm showing y'all problem number 8, and that's what I need. Okay. So we're not just getting percentages now. It's actually the first thing we got to get, but we're doing this extra step of whatever this percentage is, it's going to be out of 1,000 eggs. And that percentage of 1,000 eggs are what we are expecting to hatch within those days. So you got to find a percentage, turn it to a decimal, and then multiply it by 1,000. So A is 19 to 23 days. I wrote these 4 percentages. If we add them all up, we're going to get 95%. I'm going to put that over here to the side for just a second. Okay. But again, if you notice, they're both 2 standard deviations away. 23 is 2 up, 19 is 2 down. If we go back to the original 68, 95, 99.7, 95 is 2 standard deviations. So, that's one where the regular curve could give you the answer just as easy in terms of the percentage. But I have to figure out how many eggs are being incubated. So we turn 95% into a decimal. We're going to move the decimal 2 spots to the left, which is going to give us 0.95. Let me change colors. Still differentiate it a little bit. 0.95. Then we multiply that by 1,000 eggs, which is going to give us 950 eggs. So that's all you got to do for the rest of them. Just whatever sections. Again, y'all can fill in the other 4 percentages. I saw some people kind of getting stuck with the fewer or the more, primarily leaving off these tip ends. Okay. So those tip ends, the 0.15s, either some people were leaving them off when they needed to be included, or including them when they need to be left off. So, look specifically within whatever each question is asking you in terms of those. Okay. All right. So that's standard deviation and normal distributions. I'll make a shorter video about z-scores, and hopefully this should help you on this last lesson before our test. Okay. So until the next video, this is Coach Scharf, and I will see y'all in class.